When you gaze across Hong Kong's urban jungle, you'll notice that its distinctive skyline seems to disappear amidst the bustling commercial districts. But did you know that Hong Kong has long been one of the world's most densely populated places? With nearly 7.5 million residents calling this metropolis home, our city thrives with life and energy, forming a unique architectural tapestry that weaves together housing estates, commercial buildings, hotels, stations, and shopping malls with its famous skyscrapers. Welcome back to another exciting episode in our series, Sustainability in Action. I'm Ross Vermeer. In our previous episodes, we explored sustainability in clothing, food choices, transportation, and energy. Today, we shift our focus to a topic that directly shapes our daily lives, yet often remains unnoticed: buildings. In this episode, we'll see how Hong Kong's architectural wonders hold immense potential as we pursue a sustainable future. And we'll gain invaluable insights into the pivotal role the building sector plays in paving the way towards a greener, more sustainable world. But before we dig that deep, let's learn a little more about the buildings right here in the vibrant city of Hong Kong.
According to the latest information from the Hong Kong Green Building Council, Hong Kong boasts an impressive number of buildings, over 44,000 of them. Among them, more than 8,000 are high-rises and skyscrapers that adorn the city's skyline. These buildings, however, have a significant impact on Hong Kong's energy consumption. In fact, activities related to buildings contribute to about 90% of the city's total electricity usage, which is much higher than the global average of 40%. As a result, buildings in Hong Kong are responsible for a substantial 60% of the city's greenhouse gas emissions. To address this issue, the Hong Kong government announced the Hong Kong's Climate Action Plan 2050 in 2021, aiming to achieve carbon neutrality by 2050. Among the plan's 4 major carbon reduction strategies, energy saving and green buildings holds a prominent position. This highlights the crucial role of developing green buildings in Hong Kong's journey towards carbon neutrality. By prioritizing energy efficiency and sustainable building practices, Hong Kong can make significant strides in reducing its carbon footprint and creating a more environmentally friendly future.
To put it simply, buildings in Hong Kong use a significant amount of electricity, which has a major impact on the city's greenhouse gas emissions. This presents a challenge that must be tackled as we work towards a more sustainable future. The concept of green buildings has gained popularity in recent times as a potential solution. Now, let's turn our attention to Kevin Chu, who will shed some light on the definition and significance of green buildings.
Many people might associate green buildings with features like green walls and solar panels. In fact, the concept goes far beyond aesthetics. Green building is a comprehensive approach that encompasses the entire life cycle of a building, starting from site selection, design, construction, operation, and even demolition. The primary goal of green building practices is to minimize the environmental impact of buildings while promoting the well-being of its occupants. In essence, green building is about thoughtful planning and implementation throughout every stage of a building's existence. It involves adopting strategies and technologies that reduce energy consumption, conserve water, promote sustainable materials, enhance indoor air quality, and create spaces that support the health and comfort of the people who occupy them. By embracing green building principles, we can create structures that are not only environmentally friendly, but also contribute to a sustainable and thriving future for both the natural world and the individuals who inhabited these spaces.
As Kevin Chu has highlighted, minimizing the environmental impacts throughout a building's life cycle is crucial. This requires planning carefully and embracing innovative building methods. Today, we have the privilege of welcoming another distinguished guest, engineer Dr. Conrad Wong, Vice Chairman of Yaoli Holdings Limited, who will graciously share his perspectives on the construction industry, focusing on how Yaoli Holdings Limited has been recognized as one of Hong Kong's pioneers in actively adopting innovative methods of construction and building information modeling, or BIM, in their construction projects.
We actually, over the same time, Yaoli start changing the method of construction. We're using a lot more what we call prefabrications and large steel panel formwork. And in about 10-15 years' time, we virtually get rid of all the timber that is required on site. And that actually turned into a business. So that's why we are manufacturing a lot of these prefabrication products in China now. So to me, green, doing sustainability, is not only a duty, but also a very lucrative business opportunities. We can do a lot more sustainability from an engineering angle. I'll give you a couple of examples. We talk about timber. Now we are using a lot more prefabrication. And recently we introduced a new construction method called MIC, Modular Integrated Constructions. Basically, you build a box, and within that box, a concrete box. Everything inside, furniture, lighting, timber, flooring, are all constructed. And then we ship the box from our factory in Guizhou into Hong Kong and assemble it on site. So the way that I see construction nowadays is like a big assembly plant. All you can think about is a big Lego set. So all the components are manufactured in China and ship it to Hong Kong, and then we just assemble it. This type of construction not only saves a lot of timber, it also saves a lot of energies because the construction period can be shortened by 15 to 25%. So it's a much more environmentally friendly method. The wastage has been reduced by over 40%. So every single indicator these construction methods are superior than the current prefabrication methods. We're using BIM, Building Information Modeling. Basically, now what we do in construction is we will have the whole building designed into computers, three-dimensionally speaking. And then we assemble the whole building into a computer first, identify all the crashes, and then we solve the crashes, what we call coordination, in the computer, of course, between different parties, before we actually build the actual building. So we used to just do the 2D drawing and then construct the building. Now we do 2D drawings, 3D in computers before we do actual physical constructions. Now it's obvious, everybody doing it. But say 10 years ago when I say, no, we need to go into BIM.
BIM enables companies and contractors to make more accurate cost estimates, resulting in significant reductions in material costs, environmental costs, and labor hours. But a key sustainability challenge lies in the carbon embodied within buildings themselves. Embodied carbon includes the carbon emissions released during the extraction, manufacturing, transportation, construction, and disposal of building materials. The building industry has been actively exploring various material compositions that minimize this carbon footprint. Now, let's hear from two more esteemed guests, Mr. Shervin Shargi and Mr. Jim Lam, as they join engineer Dr. Conrad Wong to share their expertise in concrete, which is known to be one of the most carbon-intensive materials used in building construction.
concrete is one of the most carbon-intensive materials that we make out of any product or any material globally. It's also the most consumed, the most made material by mankind. So it has a very direct impact in terms of the climate emissions and atmospheric CO2 levels. What we do to minimize that is firstly to replace virgin materials with waste materials. So we do not rely on excavating, transporting heavy raw materials long distances, which has a significant carbon footprint. We use local waste materials, which otherwise would be sitting in landfill, and they travel much shorter distances. So we look at circularity of materials within Hong Kong, and we also manufacture within Hong Kong. So by reducing natural resources and replacing them with waste, we reduce carbon footprint. By shortening transportation distances of heavy materials, if you think about concrete and the materials that go into it, they're very heavy. And so transporting those generates a lot of carbon emissions, whether it's by ship or by truck. So we actually conducted a life cycle assessment under the ISO 14040 framework. So we have a fully quantified carbon footprint saving data versus conventional concrete. And actually a very large proportion of that, a meaningful proportion of that, comes from reduction of transportation distances. We've quantified our carbon savings, depending on the product and our design mix, is between 19% to 41% lower than the conventional concrete equivalent. So we substantially reduce the carbon footprint of our concrete because we use waste materials, not virgin materials, and we take those materials locally, we manufacture locally, and the end product is used locally as well. Again, true circularity. In terms of waste, we have no wastewater. We have no airborne emissions because we don't heat or melt the plastic. And there are no chemical emissions. So it's actually a 100% clean process. There's no wastage generated by the plastic recycling. The only wastage we ever create is concrete waste in terms of bricks that, for example, don't pass quality control. But again, we've designed our product to be fully recycled. So we can recycle all of our waste back into new bricks. So actually, our target in terms of sustainability and environmental impact is to minimize virgin raw materials, but also be zero waste. So any wastage, concrete wastage we produce, we will recycle back into new products. And because of our process, which doesn't involve heating, melting, or chemical processing, there's actually no wastewater, effluent, or airborne emissions from the process.
So one of the biggest wave that hitting the construction industry, as far as the green or sustainability is concerned, is embedded carbon. So what it means is when we put up a building, we have to calculate the material inside that we used, how much carbon is embedded. For example, concrete. Concrete has cement, aggregate, and sand. So where does sand come from, where does aggregate come from? During the process, how much carbon generated to make, for example, 1 kg of cement. So this is embedded carbon. So what the whole industry is thinking is how we can reduce this embedded carbon. Take concrete again, for example. If we put fire ash or GGBS, which is the waste product for cogeneration for fire ash, and GGBS is a waste product coming from the steel manufacturing process. Putting the concrete, you actually can lower the carbon emissions because this waste product is in fact has much lower carbon emissions than cement. So in this way, we can lower the embedded carbon.
Decarbonization is one of our key focuses, and NWS is among the first batch of the companies joining the Hong Kong SAR government's carbon neutrality partnership. The first one is about Hip Hing Construction. Hip Hing partnered with a startup company and deployed its 16 battery energy storage system, BESS, at 13 project sites to facilitate the decarbonizing progress. BESS is a cleaner alternative as it does not produce point source pollutants and therefore reduces carbon footprint. Hip Hing is one of the largest users of BESS in Hong Kong. Moreover, Hip Hing is also an advocate of MIC, the Modular Integrated Construction. Hip Hing's first MIC project is the award-winning project, InnoCell, at Science Park, which is also the first high-rise MIC building in Hong Kong. Innosea is a 17-story building, of which 15 floors are built with 418 MIC modules. By adopting MIC, the material wastage was reduced by 30% in comparison with the more traditional construction methods.
To effectively address the carbon footprint resulting from the building process, it is essential to consider both architectural and building services design in order to optimize energy efficiency. By doing so, we can minimize the environmental impact of our buildings. And this is where green building certification systems come into play. These systems provide recognition to buildings that demonstrate exceptional environmental performance. Green building certification tools help us to comprehensively evaluate a wide range of sustainability factors throughout a building's life cycle, including energy consumption, water usage, material selection, and waste management. Each country typically develops its own certification system to suit its specific needs. For instance, the United Kingdom has BREEAM, the United States has LEED, and in Hong Kong, the widely adopted assessment tool is BEAM Plus. Now, let's return to our esteemed guests, who will share their insights into how they have incorporated these certification systems into planning their university campuses, hotels, and stations. Their experiences will shed light on the ways in which these sustainability frameworks have influenced their projects and contributed to their overall environmental goals.
Hong Kong Metropolitan University Jockey Club Institute of Healthcare was accredited with a BEAM Plus Final Platinum rating by the Hong Kong Green Building Council for its green campus design. Officially opened in January 2021, the 13-story building is located at Sheng Shing Street, Ho Man Tin. With over 30% of the site area covered with greenery, the building incorporates many energy-saving and environmentally friendly facilities. Some examples are the rainwater harvesting system for irrigation, water-efficient fixtures, and air quality enhancement devices. Energy-efficient light fittings and renewable energy devices, such as a solar energy system on the rooftop, are also installed.
By selecting proper material and highly efficient equipment at this campus, annual energy consumption is reduced by over 1 million kilowatt-hour, about a 24% reduction from the baseline model. For water usage, we have procured sanitary fitments that could reduce freshwater consumption by about 6.5 million liters annually. In addition, a rainwater harvester is also installed to collect rainwater. It can collect about 0.9 million liters of rainwater annually, which will be used for landscape irrigation instead of using fresh water. In terms of building design, this campus is a curtain wall building. We used low-emission glass and integrated glass units to lower the solar heat gain while maximizing natural daylight to get into the building without bringing extra heat. Less heat from outside means less burden to the air conditioning system, hence less electricity to be used.
Sustainability development involves many aspects of work, including energy saving, water saving, human comfort, greenery arrangement, material selection, transportation, and technology integrations. And all requires different professionals to collaborate to achieve the goals, and it takes time to manage. It's also very challenging to get the right balance for achieving the functional and sustainability requirements and controlling them within the budget. For instance, we want to have more green space or plant room to house the equipment for green features around our campuses, but could only add a little because of limited circulation space. As you know, the space is precious in Hong Kong, especially at our university. Sustainability development is also a continuous process, and it needs an ongoing commitment for resources allocation to maintain the original target.
We also strive our best to promote energy saving. If you look around the hotel, you can see that we maximize the use of natural daylight. And also, we have grey water recycling system and also renewable energy by installing over 121 pieces of solar panels on our rooftop. Sino Group is one of the 5 developers to pledge towards net zero carbon. We set interim targets to reduce our energy saving, including 2030 sustainability vision goals, as well as striving towards net zero carbon. But this is a journey that we need to work harder together. So just looking at the Fullerton Ocean Park Hotel, we do have an array of decarbonization strategies. So for instance, we have EV chargers available for our hotel guests. When they park the cars, we hope to promote EV charging facilities. In addition to that, if you look around our hotels, we also ensure to have natural sunlight so that we can also help to reduce energy equipments. We do have energy monitoring and energy sensors as well that can also help to reduce the energy. Circular economy is a big step towards decarbonization. So we do work with EcoBricks to have the EcoBricks footpath to help to reduce the embodied carbon during the construction stage.
In about 2011, I became the chairman of the Hong Kong Green Building Council. So I got involved with a lot of green buildings. How do I promote green buildings? I want this hotel to be as green as possible, using as little energy as possible. After a few years, we built the hotel. I think it's one of the, if not the greenest high-rise hotel in the world. We managed to cut down close to 60% of the energy. In fact, the actual figure is 58.5. That hotel became very famous because we got 4 highest green building ranking awards. We got the Hong Kong Green Plus Platinum, the Singapore Platinum, China 3-star, and the American NEEDS also Platinum. So this is one of the very few buildings in the world actually achieved that 4 good building standard. And so we managed to cut down close to 60%, and then we showed to the industry, this can be done. Using this technology, LED lighting, we have sort of one of the largest hot water panel in Hong Kong, and then we use a thing called heat pump, which use, for example, the waste heat from the air conditioning system to heat up the water. So basically, we don't need any burner to heat the water up at all, most of the time. I think maybe 2 or 3 days in the year, we need to turn the boiler on, otherwise, no, we don't need to turn that on at all. And we have a lot of newest IT system. We managed to get hold of a professor from PolyU to develop an AI system controlling the air conditioning system in my hotel, which cut down another 25% of the energy from the air conditioning system. So we did a lot of things, and it was at that time very, very advanced. And then we showcased to the industry. I give them my energy bill, so this can be done. I tell them that, so green is not a cost, but an investment.
As a station architect, I have the role to deliver station design, which is in green and low carbon. Actually, it's our aspiration to keep cities moving sustainably. All our new stations are designed to be environmental friendly in the outset. We will employ technology like energy efficient chiller plants, solar cell, and where possible, naturally ventilated station. Hinking Station, it's an above-ground station. We have heavily crafted the design of Hinking Station to blend with its surroundings, integrate and connect with its existing district facilities. Also, the design of Hinking Station maximizes the use of natural daylight, natural ventilation. To achieve this, we have done cross-ventilation, a sun shading device on the roof and on the side of the 2 platforms. In addition, solar cell, which is clean and renewable energy supporting our station operation, reduce our overall carbon footprint during operations. Another features of the station, actually, it's an extensive green roof of 5,000 square meters. it would act as an insulating layer, minimizing the heat transmission into our station. On top of the connecting mobility, we are keen to utilize our unique location of our green station in harmony with the beautiful settings of nature and in harmony with what happened in the surroundings, contributing to the well-being of the community.
So apart from our stations, we also incorporate green building designs in our property developments. And we're delighted that over the last 2 years, 8 properties in our portfolio have achieved BEAM Plus Gold or Platinum ratings from the Hong Kong Green Building Council's BEAM Plus scheme. Going forward, we've committed to all of our new stations and property developments achieving at least a BEAM Plus Gold rating.
At this point, you should have a much deeper understanding of the tremendous efforts our speakers have made to achieve sustainability and the significant challenges involved. Embracing innovative products and practices in the building industry is no easy task. It requires firm commitments to new technologies and approaches. And speaking of such advancement, our speakers make a convincing case that businesses must take the lead in driving meaningful change. Let's continue to learn from their insights as they explore the role of businesses in spearheading change and leveraging sustainability challenges as valuable business opportunities.
Obviously, innovating new products and new solutions is always a challenge, and trying to change very established business models. So if you think about the industry that we serve, the construction industry, it's a very large industry. It has very established processes, established supply chains, established protocols. So bringing new innovations into these established frameworks and convincing lots of different stakeholders to change their business model, to change their processes, is a very challenging part of bringing innovations into the real world. There are a lot of wonderful innovations within universities and research institutes. The real challenge is actually how do you bring those into the real world? How do you scale those solutions to create the maximum positive impact that they can bring? So it's that interaction between innovation and real-world application, which I found to be one of the biggest challenges when looking at innovation and startups.
Recently, some of my engineers worked with a company in Shenzhen and developed a container-sized battery, basically. It's about 17,000, the handheld battery that you have got, but this is a big one. Why will you have to use such a big battery on site? It's because most of the project, the electrical company cannot give a sufficient power to us to operate all the plant and equipment on site, especially the tower crane that we use are really heavier and heavier, and they use a lot of energy. So we have to have employed a lot of diesel generator on site to supplement the electricity that we need. Now, even though we are buying biodiesel, but still that will have some carbon emissions. Now we developed this big container-sized battery. You can charge them during the nighttime when the site is empty, it's closed basically. And then in the daytime, they release energy. So by doing that, we cut down enormous amount of carbon emissions. So I give my team a really big thumbs up. And now this, of course, this also become a commercial product. We are selling to other contractors as well. It's just beginning, but this is what we can do. So that's another opportunity. This concept. Green is gold. Carbon is diamond. Diamond is actually consists of 4 atoms of carbon. But in a sense, it is true. So if you can have an opportunity to reduce carbon emissions and better carbon, this can be a business opportunity. And you can sell it to other industry and even your competitors sometimes. So I think this is a major trend that I think developing within the construction industry, and this is what we are trying to do more in the future.
It has been inspiring to witness the commendable progress made towards sustainability in Hong Kong's building industry. But we also must not overlook the significant role Hong Kong's government has played in this journey by implementing a range of incentives to encourage building developers to embrace sustainability practices. For instance, capital expenditure incurred in the installation or construction of energy-efficient building systems qualifies for profit tax reduction. In addition, buildings participating in the Beam Plus scheme are granted an increase in gross floor area, or GFA, of up to 10%, allowing for the inclusion of balconies, prefabricated external walls, common corridors, and clubhouses. While we appreciate the efforts made by industry and the government in developing a sustainable built environment, one in which buildings are designed for longevity, flexibility, adaptability, reuse, and recoverability, we must also confront our own responsibilities as owners and occupants. We too can contribute by taking advantage of our building's sustainability features, reducing our consumption of electricity and water, and minimizing waste, both at home and in the workplace. Thank you for watching, and let us continue to strive towards a sustainable future.